Hello all. Today we will start our first SAT topic, that is real numbers, exponents and radicals. So first of all we will see what is real number. So real numbers, how we can define them. So those numbers which can be located in a number line are called as real numbers. The numbers that can be located in a number line, whether it is rational or irrational. Number line. So all those numbers are real numbers. Now, what are the types of real numbers? You can categorize real numbers. So these are the subsets of real numbers. First is a rational number, and second is irrational number. So rational numbers are those numbers which can be expressed in a fraction p over q form where q is not equal to 0. Also, uh, terminating decimals and repeating decimals are rational numbers, whereas non-terminating and non-repeating decimals are irrational numbers. Or we can say that all those numbers which cannot be written in a fraction are irrational numbers. So if we give some example of rational and irrational numbers, then any integer like -5, 4, 0, then any fraction like 2 over 3, 5 over 9, 7 over 5, that means any proper or improper fraction, we can take any of them. Then we can take any terminating decimals like 0 0.25, 0 0.38, and any repeating decimals like 0 0.3333, like this, which we can write as 0 0.3 bar. So these are the rational numbers. If we say about the irrational numbers, then those numbers like uh, any number like pi, which has an estimated value of 3.14, but that's not the exact value. So it is always non-terminating and non-repeating. Similarly, E has an estimated value of 2.71, but again that is not the exact value. So again it will be non-terminating and non-repeating. Next, we are having any number in the square root which is not a perfect square, like square root of 2, square root of 3, but square root of 4 will not be the irrational number. Then square root of 5, and then directly then any non-terminating and non-repeating decimals like 0.12597482415, like these numbers, where neither it is repeating nor terminating. So these are the irrational numbers. Then next we have to learn about this is irrational number cannot be categorized further, but rational numbers are having some subsets, and those subsets are fractions, integers, uh, whole numbers, and natural numbers. There are many more if we say odd number, even number, like that, but we will say up to here only. So this is what we have to learn in real numbers. Now coming to exponents. So in exponent, basically we have to learn exponent rules. So what are the exponent rules we have to learn? The first rule is when the bases are same but powers are different, like exponents are different. So we can say a to the exponent m times a to the exponent n. That can be written as a to the exponent m plus n. Similarly, number two, a exponent m over a exponent n, that is equal to a exponent m minus n. Number three, a exponent m to the exponent n. So that is a to the power m times n. Then we are having a to the power negative m. That can be written as 1 over a exponent m, or this can also be written in reverse, like 1 over a exponent negative m can be written as a exponent m. Number 5, anything to the power 0, like a to the power 0 is equal to 1. Number 6, this is related to radical. So if it is nth radical of a exponent m, that can be written as a exponent m over n. Then number 7, we are having when the bases are different but exponents are same, like a exponent m times b exponent n, then this can be written as ab x, sorry, here b exponent is also m, then this can be written as ab exponent m. So these are the exponent rules. Now suppose there is a question and the question says if 3x minus 2y is equal to 5 and 8 to the power x over 4 exponent y is equal to m, then find the value of m. So here you can see how we'll be solving this. You can see base is also different, powers are also different. So first thing which we will be thinking here is either we have to make powers same or exponent same, or we can make the bases same. So what we will be doing here, if you will see, 8 can be written as 2 cube, 4 can be written as 2 square. So we can write this as we are having 8 exponent x, 4 exponent y. So we will be writing this as 8 exponent x over 4 exponent y is equal to m. So this implies that 8 can be written as 2 cube and to the exponent x divided by 4 can be written as 2 square to the exponent y, that is equal to m. Now how we will be writing this? This we can write 2 to the exponent 3x over, using the rule, then 2 to the exponent 2y. Now you can see we are having same base and different exponents. So, and this is in division, so we'll subtract the exponents. So what we can write from here, this implies that 2 to the exponent 3x minus 2y is equal to m. Now in the question you can see it's given that 3x minus 2y is equal to 5. That means we can write this as 2 to the exponent 5 equal to m. So from here we can say m is equal to 2 to the power 5, which is 32. So that will be the answer. So this is how we will be evaluating the questions of exponents. And also we have to remember these rules of the exponents. Now coming to radical. So in radicals, what we have to remember is, see, first of all, how we define radicals. So there are two parts of radicals. Suppose here it's M and here it's A. Then this is called as radicand and this is called as a radical. Now there are some rules for radicals. Mainly we will be talking about the square root radicals, but we will be a little bit of we will see other types of radicals as well. So the first thing is rule about addition or subtraction of radicals. Addition or subtraction of radicals. So how we can add or subtract radicals? See, first thing we can convert them into uh, decimal numbers and then we can add or subtract. But if you will see many questions, it is only asking to simplified radical form. We have to answer it only simplified radical forms. So in those cases, what we will be doing, like see, the rule about addition or subtraction of radicals is to add two or more terms containing radicals. The radicand and radical both should be same in all the terms. For example, if we are having square root of 2 plus square root of 3, then you can see a radical is same, that is 2, but radicand is 2 and 3, so can't be added in this form, can't be simplified in this form. Now suppose we are having 3 square root 2 plus 5 root 2. Now we can add them. So root 2 you can treat that as variable. So you can see it's 3x plus 5x types of questions. So we will simply add them. So that will become 3x plus 5x is 8x. So here it will become 3 root 2 plus 5 root 2 is 8 root 2. Even if we need to subtract, then we can subtract like this only. Now, next rule is about multiplication. So in multiplication, we have different rules. First, if see, first we will be seeing here when radicals we are having just like this question. Here we are having 3 root 2 plus 5 root 2. Now when the radicals and radicands both are same in all the terms, if all the terms having same radicals, only we have to see about radicals. So in this case, what we will be doing, like we are having square root of 5 times of square root of 9. So in this case, we will simply multiply the radicands. So keeping the radical as it is, we will multiply the radicands. So what we can do from here is, for example, we are having square root of 5 times of square root of 9. You can see radical is same, but radicands are different. So we will keep the radical as it is, and square root of 5 times square root of 9, that will become square root of 45. The square root of 9 could have been simplified as 3, but if you don't want to simplify, then you can write like this. Suppose we are having cube root of 5 times of cube root of 9, then that can also be written as cube root of 45. Now, case 2 we are having, if radicals are different, if radicals are different and radicands are same, then we can use exponent rules. How we will be doing this? Suppose we are having, see, radicals are going to be different, but radicands are same. So suppose square root of 2 times of cube root of uh, we can take 2. Then how we will be doing this? This can be written as 2 to the power 1 over 2, if we will convert this into exponent, and this can be written as 2 to the exponent 1 over 3. Now you can see we are having the same base but different exponents, so they will be added. So 2 to the exponent 1 over 2 plus 1 over 3, which can be written as 2 to the exponent of 5 over 6. If we want to write it into simplified radical form, then that can be written as sixth radical of 2 to the exponent 5, which can be simplified as sixth radical of 32. So this is how we can simplify in case of uh, different radicals but same radicals. Yeah, radicands also can be different, like here it could have been 4, but that can be converted into same radicands. So those are the cases. And case 3, if both are different, if both radicals and radicands are different, and also they cannot be converted into same radicands, then like cube root of 5 times of square root of 2. So we cannot do anything here. Neither we can simplify this in radical form, nor we can evaluate this in this form, but we can do this in radical form. So we can say can't be simplified in this form. So these are the uh, content we have to learn in this topic, that is real numbers, exponents and radicals. So that's all for today. We will again meet in the next session with a different topic for SAT only.